Great. Thank you. It's my pleasure to introduce Mr. Brian Koenig, who's our tech ed instructor at the high school. He's been doing it for 40 years. I didn't realize that till just he shared that with us. That's amazing. All the kids have benefited from his great program and the great leadership he has there. And just to let you know, the whole month of February will be dedicated to school-related programs that, among many of our outstanding programs, but Brian's going to be the first. Again, it's with great pleasure that we've got Brian here. He's going to share some information about his tech ed programs that he's been leading for such a great length of time and for such a great job. Thank you, Brian.
Thanks. So I want to talk to you about a couple things today. I'll try to keep it tolerable. So I have a little bit of paper to throw at you, and this might help you look at some big picture things. Sure, if you would. I'd appreciate it. Thanks. And then I have another little group of things, and this I don't have enough for everyone, but I have these per table. So when I talk a little bit about some of our additive and subtractive modeling, it might help you to think about what's here. There's a couple more. Your table's pretty full. You guys do. So we can talk about that. So, thanks, Tom, again for welcoming me. It's nice to see familiar faces from the school district. Tom served us so well as a board member for so long, and Mr. Lehman, of course, here was a super supportive boss in our technical ed program for years, and a good guy to be around, good guy to work for. So it's really nice to have people here that have been so proactive for our school district. So I teach tech ed at high school, and tech ed used to be woods and a little drafting and a little metalworking, and now it's changed quite a bit. And so the thing that you have in front of you is a handout we gave to parents last night, so it's really, you saw this one yourself already. So, but on here we list kind of the courses and kind of the direction that we take students through. So I'll just kind of go across and talk a little bit about what the courses entail. I talked a little bit about some of what we do in our advanced classes. So we teach a broad variety of drafting and CAD related classes. So on the top row, that's what this is. So we teach one mechanical drawing class that's really pencil and paper. And then we've done AutoCAD at high school since about the early 90s. And AutoCAD is the standard for CAD software in industry. So everybody's expected to know AutoCAD in industry, just like you might be expected to know Microsoft Office if you were working in the word processing industry. And so now our mechanical CAD class is transcripted through Chippewa Valley, so our kids get college credit, 3 credits for that class at no charge to them, pretty good deal. And our advanced classes that are on the top row, those mechanical CAD courses, are in SolidWorks. So some of you, if you're familiar with mechanical design, may have heard of SolidWorks, and that's kind of the next step up in design. And those are also transcripted. So our drafting and CAD students can get 9 college credits, and I have a bunch of juniors and seniors this year that will, at the end of the spring quarter, will have 9 college credits. We also teach architectural CAD on alternate years, and so that's house building and also designing a house plan of their own to whatever kind of house they like. Last year we started doing something called Autodesk Revit, which is 3D architectural design, which is a really over-the-top, interesting, really cool piece of software. I took a 40-hour class up at St. Paul College before I taught it, thank goodness. I was the only teacher in the group. So everybody else was architects. And so, and a lot of them were younger than me. But anyway, it was interesting to go there. It's really interesting that they say that the only people coming into their firms have to know this new piece of software. Autodesk Revit is the bomb in commercial design today, so you have to know it. So our kids got a good taste of it, and so it's kind of a fun thing to be able to share. And some of you that I know here are aware of this, but during the summers for the last 20 plus years I've worked doing SolidWorks design in Minneapolis for a firm. So I just go in and take a desk and I design and project manage for those guys for the summers. So been a great experience for me, and really I think it's helped me to be interested in it and also to help push students in a direction, because I think a lot of times kids don't really get a real experience if they don't have somebody who's really done something. So for me, I like it. It's fun. Related to our CAD, I just thought I had to bring this because you guys are the Kiwanis. So I made this little sign on our plasma cutter at school, so I'll leave it with you. Anyway, it's nothing real special, but it's kind of fun that we have technology at our school now related to CAD that allows us to do things like this. And this is cut out with a plasma cutter at the high school out of a piece of 16 gauge steel. Pretty accurately, that all cut out in about 4 minutes. It was just cut it out. It took a little longer than that to design it, but not much. I took the design off the internet. I hope it isn't patented. Anyway, so just kind of to show, it's kind of fun to do stuff like this where you can kids especially can step in, design something, and see it cut out on our plasma machine. So that's a new feature at the high school. This plasma cutter is a really amazing piece of equipment, and this is what we call subtractive software. So we take something and we use it to cut away from something to make a finished product, right? So that's subtractive. And so cutting, machining, all those kinds of processes are subtractive. And so the concept of CAD really goes along with that. And I have this other thing that's in front of you, and it might be a real boring looking thing. It would be nice to have it on the overhead, but I don't know if Larry had SolidWorks on a computer for me up here. And it doesn't run on our laptops at school, so I couldn't really bring it and show you. But I want you to look at this, and maybe you can look at it with a partner. This is a solid model that uses what we call intersecting technology. So you guys from math class probably know what additive stuff is, right? 2 + 2. Or additive technology might be like building a house, where we nail boards together to build a house. So this, if you look at the front page, this looks like an eggshell. Maybe looks like a hood on a car. In the second page, you'll see 2 shapes that intersect each other, right? In the third page, you'll see that the bigger shape has been hollowed out. All right, this is done in SolidWorks. This all looks kind of like, what is this, right? On the fourth page, you'll see that we've also added a grid work on top of this in one direction at a bias. On the next page, you'll see that now we have a 2-directional bias on top here. So this looks like a mess. It looks like maybe a cheese grater or something. Then turn the last page, see what you see. So in SolidWorks, we can take disjointed solid bodies and intersect them. So mathematically, intersection is only keeping what these things have in common. So all these shapes here started out as separate entities, but using our CAD software, we can subtract, basically intersect, so the only thing left is what all of these shapes had in common. It's pretty cool. And I think that when we started drawing this, we just did this one recently, I brought it because we just finished it this week, and they were all kind of like, what is this? And it doesn't always work perfectly when you do stuff like this, but it's interesting that somebody out in the design world that's designing cars and trucks and airplanes and complex shapes, what they do, instead of just drawing a picture and making it into an airplane, they draw complex shapes and intersect them until they come up with kind of a hybrid shape for 3-dimensional solids. So this thing could probably be made by 3D printing, but it'd be a very difficult part to actually make out of metal or plastic or wood because of its complex shape. So part of the idea for our advanced kids, I think, is to get the theoretical part of things. So we talk a lot about doing stuff in tech ed, and this is just really a good way to get people thinking about doing stuff. And it's nice to have girls and guys in our CAD classes because there's a high demand for females in architecture and engineering and basically all the trade-related fields. So it's nice to see this kind of work kind of get a chance for the kids to see it. And this is a little cooler on the computer. I'm sorry, I just couldn't make SolidWorks happen for us up here today. So I also, as long as we're talking about this additive and subtractive and intersecting, this kind of fell apart. This is 3D printing. Most of you all are familiar with 3D printed objects. And these models were all made in SolidWorks. And we have a MakerBot computer printer at the school, a 3D printer. And so these parts were printed as separate entities, and they actually work, although it's hard to make it work up in the air. This is a ring and pinion gear, and I wanted to buy one of these to show my power classes, and they were $150, so instead I had one of my students design it, and we made it for about nothing. So that was a good deal. And this is just another example, and you're welcome to handle these. I don't think I'm going to send them around, but you're welcome to take a look at them. This is just another SolidWorks part. This is additive manufacturing, where we take a model and a layer at a time, about 5 millimeters at a time, or half a millimeter at a time, excuse me. We build this up out of molten plastic with a 3D printer. And so a student can design this, and this was 4 hours later, this was printed. So in today's rapid prototyping industry, we can make real pieces that we can touch and feel and look at, even with equipment we have at school. So our 3D printer is not a crazy over-the-top piece of equipment, but it's pretty cool, and kids get a chance to use it.
Isn't a 3D printer, aren't you normally starting with a block and taking off of the block?
Actually, most of the 3D printers are additive. Yeah, they mostly are. So there's different ways of doing it. If we're starting with a block, then we're doing some sort of machine process. It's a great question, but most 3D printers do that. Phillips Plastic up in Hudson has, I think, 6 different 3D printing technologies they use up there, but they're all additive. Some of what they do is metal. They can actually make metal parts up there. So unique things. So our top row of this has to do with design and drafting and 3D printing. And I showed some people last night these couple things here, but since I heard this bias towards the Kansas City Chiefs today, I knew that somebody here probably likes sports, so this was something that we did as just put it on a piece of wood or something hanging on the wall. So this is a state of Wisconsin, but a Brewers mitt, and pretty well placed. Obviously, it seems like the Brewers have been doing better than the Twins, so you'll see more Wisconsin things cut out with Wisconsin emblems and Minnesota stuff lately, and don't even get me going on the Timberwolves. Anyway, it's fun because I think lots of times kids, especially with this is done on our plasma cutter, that it's fun for them to do something that they love the Packers, or they love the Badgers, or they love Ford or Chevy or Skidoo or whoever, and they cut something out that they can use. It's cool to hang in your garage, or use for other reasons. So that's part of our welding technology, but it's also that's subtractive. And then this little guy is just a little decorative thing. Also, this was done off a bitmap off the internet through Photoshop. And our software converted a bitmap into a toolpath, and this was about 60 seconds of cutting. And kind of cool. I made a few of these for my wife for Christmas time, so still hanging, a couple of them still hanging up in our house at home. So kind of fun to do things that are big and complicated, sometimes fun to do things that are small and not expensive, and maybe just kind of entertaining to do. I don't have a timepiece here, and I don't want to put you guys over the top. We're good? Okay, all right, thank you. So in the second row across here, we have some wood opportunities. So we have a really gorgeous wood shop at the high school, and first semester we teach a wood fundamentals class, which is typically freshmen and sophomores, and they learn basics of building cabinets, some materials science, woodworking material science, and a lot of safety things. So we do a lot of machine safety, so we want to keep people from getting hurt out in the shop, and then we do a woodworking project, end tables, nightstands, coffee tables, that sort of thing in our wood fundamentals. Then going across, these are advanced classes. Our cabinet making classes allow kids to build things that are more of their choice, maybe gun cabinets or dressers or desks or bigger projects, more than what they choose. So in the first class, I kind of pick a group of projects, let them choose from them. In our advanced classes, we try to let kids build what they want. And so these promote really the cabinet making and furniture making skills, and there's a great demand in the construction industry for trim carpenters, and there's also a great demand in the furniture industry for people that can do those kinds of things. CVTC in Eau Claire has a furniture making and cabinet making class, and their placement's always 100% because there's so much demand for kids and young adults that can do woodworking crafts and skills. Construction technology, some of you have been around the high school. At our new high school in the north end, we have a building that we built in construction tech 2 years ago, and another one on the girls softball field that we built. And that our guys and gals get to go out there and build structures, build floors, walls, roof, do shingles and siding, and learn really how houses are built, but we don't typically build a house. We typically build like a garage or a utility sheds. So these are all semester-length classes, so it helps you to think a little bit about, in that period of time, what we do. That's kind of our core of our wood stuff. At the very bottom, you'll see this home maintenance class. I'm teaching it right now, and that class is wall framing. It's electrical wiring, so we actually wire real circuits. Two-way switches, three-way switches, four-way switches, switch outlets, circuit breakers. We actually put a panel in, so the kids are actually installing breakers in a panel, and it has to work. We have to plug it in. We have to not blow any fuses. We try to keep people safe electrically by keeping it unplugged when we're not testing it. When we test it, I make everybody get away We plug it in and we just then one group at a time test it, but we will build walls. When we get the wiring to work, we take it all apart and we bury it with sheetrock. And so we bury it, we tape it, we finish it, we paint it, wallpaper it, or use ceramic tile. And somewhere in that, at that point, I actually take out a hammer and punch holes through the walls, and then teach kids how to fix damaged sheetrock, because it's a great college skill to have, great young life skill to have. One of the last years I taught, I had a student came back, he had graduated, and he came back and he said, "Mr. Koenig, I think you saved me $800. I said, "I don't know how I did that." He said, "Well, I punched a hole, or somebody punched I think he said, somebody punched a hole in the wall of our apartment, and they were going to take our damage deposit." But he said, I know how to fix that. So I got a little piece of sheetrock, and I patched it, and it was good. And so we didn't have to give him our damage deposit. He said, "So thanks a lot." And, so for me, it's like, it's fun that somebody had the incentive to break the hole in the wall to begin with, but then also to fix it, and to think that it was a good deal. So that's, home maintenance fits into our woodworking part of class. And so a lot of variety of kids. Home maintenance, you'll notice on the bottom it says there's no prerequisite for, so anybody can take it. So I've had some seniors take it, never took another tech ed class their whole high school career, and they came in and took it, and still were able to get in and have some fun with it and learn something. So some of our classes, of course, you have to take an earlier class to get into it, but a lot of these, we want to encourage kids to get exposure to our fields. So on the other end of our shop, if you've been in the building, we have a big welding shop at the high school. And so we have a welding fabrication class that's always been big. Last year I had 40 kids in welding first semester, 2 sections. We have tremendous equipment, tremendous welders, and really just it's been a great fun time for me, but also enjoyable time for kids to get out there and use gas welding, arc welding, wire feed welding, plasma cutting with a hand torch and an automated torch, cutting torches, and really just get a taste of welding. Welding is in such high demand. I talked to employers around here, talked to our tech colleges, and a year and a half ago I had a student come in. He'd graduated 2 years before. He'd been working a rapid oil change since he graduated from high school. He said, "I hate my job. I hate changing oil." He said, "I'd like to do something else." And I said, "You know what? I remember that you were awfully good at welding." I said, "Why don't you get a job in welding?" "Oh, I don't think anybody's hiring." So I said, "Well, why don't you come back and catch me sometime, catch me in a week." So I called Trinity Meyer in Hager City, talked to HR, and I said, "I was wondering if you guys have any openings for welders," and the lady started laughing. And I said, "Well, I didn't think that was that funny, but they cut me into the joke." She said, "Well, the reason I'm laughing is that we have 32 positions that we have unfilled right now." And I said, "Well, I have this young man I had as a student, and he's a really good welder." And I said, I think he could work for it." She said, "Send him down today. Send him down today. And if we need to train him, we'll put him in the Red Wing Tech, Southeast Minnesota Tech has an evening program. We'll pay for him to go to school. We'll hire him now, and he can work here, because that's how hungry we are for welders." Welding is a big demand. DCTC in Rosemont and New Richmond, these schools that teach welding, are teaching double shifts of welding because they can't fill the openings quickly enough. So they start over there, DCTC, at 6 in the morning till noon. They run shift A. At 1 o'clock, they start shift B, and they go until 6:30 or 7 at night, and they teach 2 shifts of welding, and they hire them all out every semester, every year. They're just putting people out like crazy. So welding is a great opportunity. And I think that try to push kids in the direction of, this is the kind of stuff you need to know. And it's amazing in welding to see kids get out in the shop and just go. Sometimes people say, "Oh, kids are lazy. Kids don't work hard. Kids don't know what it means to work." You should see kids come into that welding shop and get a helmet and gloves on and go into a welding booth and weld till the bell rings, because that's what they like to do. It's pretty cool. So I really enjoy seeing that. And we teach advanced welding, which does some other techniques like welding aluminum, welding non-ferrous metals using TIG, which is a specialty process, and then doing more project stuff. So in our advanced class, we try to build projects. In our intro class, we mostly do required welds. But great opportunity for kids, a great facility, and always fun for me to see kids take this beyond. One of my graduates a couple years ago went to St. Paul to the Union pipe fitting school, and he couldn't be happier with what he knew going into it and how it's helped him to make career choices. So part of being in high school is choosing careers, and we have so much push for kids to go to 4-year schools. It's interesting that some people don't want to do that, and some people go to 2-year schools and they end up making twice what 4-year college graduates are making. Interesting thing, DCTC offers a GM-sponsored ASEP program. It's a General Motors mechanical program, and the top graduates of that class last year started out at $60,000 plus a year with 2 years of school. So think about that when you go get your 4-year business degree and start out at 30 grand a year. That all your college debt is you still owe it, and these people that are 2 years younger than you are out there making great money in a trade. So it isn't all gravy, it isn't all golden, everything has its price, but there are some people who want to make their living doing active jobs and active positions.
Have you considered moonlighting as a guidance counselor?
I think that job's filled, but otherwise, yeah, go ahead.
Listening to some of this, how do some of these courses fit into a college education? Because the reason I ask is my grandson went to U of M and in engineering, and he's a product design major. And you talk about 3D printing and all these computer program stuff sounds exactly like what he knows.
You know, you're right. I think that there's a lot of it that would apply there. And in Minnesota, the U of M is not very good about taking high school work and accepting it, but Metro State is. So Metro State University is really based on giving credit for experience. So if you did a portfolio of stuff in CAD and took it to the U of M, they'd say that looks nice. Metro State, they'd say, let's find a way to give you credits for this. And you'd pay them for it. You pay for the credits, which is their deal. But the same thing is true in some of these areas. If you have a capability that isn't recognized by another school, Metro State University, really their job is to try to take workers, mostly from the field, and help them to get credits so they can get a bachelor's or master's program. It's a pretty good deal. So, but the U of M, you might have to jump hoops. I did my master's at the U of M myself, and I was able to get credit for work that I did, but they called it an internship, so I was actually doing paid employment. But I did get college credit for doing some stuff in CAD, for example. So they do have some workarounds, and it's kind of individual by institution.
Do you know how that is?
Well, Wisconsin's a little bit different, but actually the Wisconsin schools all accept like our credits from these classes. All will go into Madison or Eau Claire or River Falls. They all go in. And while they might not be applied to your major, they're always taken as at least elective credit. So that's kind of the thing. So you take a college 4-year degree, you need some elective credits, and this is one way to get them. So, and of course, we offer a lot of other articulated classes at the high school. These are just some ones that I do at the time. And then I'm just going to kind of scoot down to the bottom here, so I'm going to kind of keep rolling. So we have our welding, advanced welding. At the bottom row, we have Power Tech and Rec Power Tech. So Power Tech is a small engines class. We learn 2-stroke and 4-stroke theory, take engines apart, put them together, and really the goal is to get them running. And so we often take junk, literal junk. One of my boys this year who took his engine apart and his whole carburetor and intake was completely stuffed full of corn. And so I don't really know how a mouse ever got in there because it was a really small space, but it was completely stuffed full of corn. And I said, I think I know why your engine isn't running. But we took it all the way apart and put it together, and boy, you should have seen him smile when he got this going, because his dad said, I don't think you're going to get this running, and he did. And so he was pretty happy young man. It was pretty cool to see. And it's kind of practical because our machines are so expensive and labor so expensive. You buy a $200 or $300 lawnmower and you take to somebody to fix for $100 an hour, you kind of might as well throw it away because it's too expensive. So when young people know how to fix something, it's like, I always say, fix a lawnmower, keep it forever. I had a Honda lawnmower, it lasted me 21 years, and I was glad for the 21 years I didn't have to buy a lawnmower because I could throw the money against anything else that I wanted to do, because I don't love to mow lawn, right? So, so anyway, it's a good thing. So maintenance and service and taking care of stuff, I think, is part of the class. And our rec power is more of large engines, snowmobiles and motorcycles and four-wheelers and fun equipment. And these programs both align with our tech colleges around here that teach small engines or teach rec power or teach automotive. And we always have a steady trickle, I'd say, of kids that go into mechanics at one level or another. We've got so many great schools around here that teach. DCTC has a bunch of programs that are great. And we also offer kids opportunity to get out and do student shadows. And that's often through guidance with student shadows and also job shadows to see what people are doing out in the field and see if it's something they might be interested in as a career. So big picture, our program incorporates kind of a little bit of all this stuff, and it's interesting for me. Since Ms. Swanholz isn't here today, or the English teachers, personally, I don't think I could teach 5 hours a day of freshman English. I don't think I could do it. Because I'd be a big hole in the wall somewhere for me pounding my head on it. It's not my deal. So sometimes my variety drives me crazy because there's so many different classes. It's always like 6 classes, and it's always a lot of variety. But it's the very thing I think that really has kept me interested in the field. It's just like I really love the variety, and really the subjects I teach, I love the stuff, and I've had experience in a bunch of the areas, but you know what, it's really cool to do something that gets people fired up, and it's something that still, it's kind of cool for me to still think that I really love doing this stuff. It's really cool, and kids just continue to amaze me in what they come in and do for us. If I got go ahead.
Obviously, the software that you're dealing with is very expensive. Do the companies donate it to the school, or does the school actually have to buy it?
Well, interesting question. We, Autodesk, who provides our AutoCAD and Inventor software, and Revit, give it to us for free, and they give it to students for free. So you can download it at home. The student can download it with a school email. They can download it and have it for free, and it only lasts for 3 or 4 years, but they can do it again. Our SolidWorks is not free. So that we pay for on a subscription, and it's kind of expensive, and I think that we got help from the foundation when we first started some of these things. And other places we did solicit some funding, and now when we do upgrades, they're a little less money. But SolidWorks is a little bit expensive, but it's kind of one of those things, you know, sometimes you just got to pay for it. So
You'd almost think that they would want the kids used to it, so as they graduate and move on, that they request certain softwares, right?
that's Autodesk saying, that's why Autodesk is in every college in the world,
Right.
in almost every school, it's everywhere, and that's because they've been proactive. And SolidWorks is getting that way, but, excuse me, there's not as many schools that teach SolidWorks. There's not as many high schools, so I think it's a little bit less common. Maybe that's part of it, but you're right. You'd think that all the companies that sell software would give it to kids. They're so used to it, they don't want anything else. There's some truth to that. So, excellent point. So, anyway, I do appreciate the chance to get a chance to share with you folks. I do appreciate the support from the community. My goodness. Our school is so amazing. This building is so amazing. Our facilities are so great, and really it's just a triumph for the community to have a building like this that's going to endure well beyond some of us that have been around here while this thing got built and got put together, and it's so good to see a bright future for kids in town. So glad for the support from Kiwanis, and glad that you invited me for lunch. Lunch was really good, by the way, and nice to get a chance to share. So check out some of the stuff if you'd like to. I'm going to leave that little sign wherever if you want it. If you don't want it, do whatever. I just brought it. I just thought I'd do it so you had something to look at. So unless there's other questions, I think that's my deal. I'll call it a wrap. Okay? Thank you.
Great job.